Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. We are going to start into section 2.7 and look at solving polynomial inequalities. I know that you probably did at least some of this last year in Algebra 2, so there's a good chance there will be some things you've already seen with this. And then what we're going to do is we're going to talk about solving a polynomial inequality a couple of different ways. For this first one, find the solution set to x to the third plus 2x squared minus 5x minus 6 is greater than 0. Well, first thing we're going to do is go ahead and graph this. So when we do that, x to the third plus 2x squared minus 5x minus 6. Now, when we graph it, it's looking for where the polynomial is greater than 0. Well, the first thing, like it says, locate the zeros, and then something that you're going to even start seeing used as a term. I think I've probably even used this some as I've talked through notes already, just knowing that this is going to be something that will come up. But, zeros, critical points, and when we look at this, these zeros are -3, -1, and 2. Well, it says write our answer in interval notation. Well, we're looking for where is the function greater than 0. Well, meaning where are the y values positive? Well, they're positive anywhere above the x-axis. So from here to here, and then from here on. So the solution to this, now here's the other key thing. Because this is just greater than 0, it can't equal 0. So our first interval is -3 to -1, and parentheses around that. Because there is a second interval, it's going to start at 2, again with a parenthesis because it can't equal 0, positive infinity. So that certainly, if you're able to use a graphing utility to do these, a lot of these you won't be, but we did at least want to introduce one with this. So the next one, solve the inequality, and here you can even see we say factor to find the critical points, again basically meaning factor to find your zeros. X squared minus x minus 6, well, what multiplies to -6 adds to -1, 3 and 2 with -3. So x minus 3, x plus 2. Now here is where you can't just say that for each of these are critical points, which are 3 and -2. You can't say x is less than or equal to 3 and x is less than or equal to -2. One of those is going to be accurate. One of them isn't. When you factor, one of these is going to be less than or equal to 0 as a separate factor. One is going to be greater than or equal to 0. One of the things that I know I've shown you in some past notes using a number line to help you graph this, something that we're going to now introduce, which again, if you guys were in Advanced Studies Algebra 2, I think there's a good chance either Ms. Griffith or Dr. Graff showed you this. But we are going to use a sign chart to where we don't even worry about what the value is. We're just going to look at whether it's positive or negative. And so when we do this, basically when we set up our sign chart, I'm going to list the two factors, and then I'm going to also list our two critical points. Now, from here, basically what we're going to do is we're going to pick a number in between these to test. You can pick any number you want. You didn't pick any number bigger than 3. I mean, I'm going to use 4. You could use 26. And then you also need to use a number smaller than -2. negative 3. So now when we plug these in, basically, and I am going to actually need one more row here. If I plug negative 3 in, negative 3 minus 3 is negative. If I plug negative 3 in here, negative 3 plus 2 is also negative. Well, we don't even care what the numbers are. What we do care about is anything that we plug in below negative 2 will give us a negative value for this factor and this factor. Well, we're multiplying them. A negative times a negative is a positive. Now, if I plug 0 in, 0 minus 3 is negative. 0 plus 2 is positive. Again, anything between negative 2 and 3 will give you a negative value. Anything between negative 2 and 3 for this one will give you a positive. So if I take a negative times a positive, my result is negative. And then one last one. 4 minus 3, positive. 4 plus 2 is positive. Well, again, anything we use bigger than 3 will give us a positive times a positive, which is positive. Now, here's the key. We are looking for where it's less than or equal to 0. Well, the only interval where it's less than or equal to 0, meaning negative, goes from negative 2 to 3. Now, because it's less than or equal to, we use brackets. So that's another option then, essentially what I was doing in some of the past sections when I showed you a number line, plugging in values. That's where you were actually looking at, okay, what does it equal? Now you're not even worried about what it equals when you multiply things out. You're just worried about, is the end result positive or negative? So, little different way of looking at things. Those of you that are looking at taking calculus next year, you will also use sign charts with some of the things Coach Lilligren has you doing with that. So, anyway, that is our second example. And basically, we're only going to look at one more example. We're just going to talk about, what happens if we make a change here. Now, for example 3, again, first thing, factor, find your critical points, and then we'll set up a sign chart. So, 4x to the third minus 12x squared. Our GCF here will be 4x squared. And then that leaves x minus 3 greater than or equal to 0. So our critical points are 3. And then here is where 4x squared equals 0, divide by 4. And when we square root, the other one is 0. Now, the thing that we do have to be aware of here, you have a multiplicity of 2. Where that's going to matter is when we set up our sign chart. So, in terms of now setting up a sign chart with our two factors, first factor is 4x squared. My next factor is x minus 3. And our two critical points are 0 and 3. So again, what I'm going to do is plug in values, a value in between, well, between 0 and 3, 1. Bigger than 3, again, I'm just going to use 4. And then in between, or from 0, something smaller, negative 1. Now again, when I plug in these values, well, here you plug or you square a negative, it's positive. Negative 1 minus 3 is negative. Well, now when I take a positive times a negative, I get a negative end result. Plug 1 in, well, that's positive when you square it. Plug 1 in here, 1 minus 3 is negative. Positive times negative is negative. And then I'm going to even mention one other thing here in a moment. If I plug 4 in, and here's kind of where the sign chart's nice. I get 4 squared is 16 times 4, 64, not that bad. let's say your critical point here had been 8. Well, you don't necessarily want to mess with 9 squared times 4 if you're trying to just quickly do this. So that's why 4 squared is positive times positive 4. It stays positive. 4 minus 3 is positive. Well, a positive times a positive is positive. The other thing you can basically look at is right here. When you're multiplying, if you have an even number of positives, it's going to be positive. Here I have an odd number, negative result. Odd number, negative result. Same thing here. Even number of positives, positive. Odd number of positives, negative. Here, you have an even number of negatives, back to a positive result there. So, we are now looking for where it's greater than 0. Well, the only interval that's positive is right here. Now, notice, this one, usually the signs alternate in our sign charts. The one instance where they won't is when you have this multiplicity of 2, and that's because if we were to graph it, you would have had a bounce. So, we are looking for where it is greater than 0. Well, where is it greater than 0? From 3 to positive infinity. And since it's just greater than 0, 3. Now, for example 4, and this is what I was saying, basically there's only one more example, is all we're going to do, everything critical points, everything sign chart will be, the same, except now we are looking for where is it less than 0. Well, the intervals where it's less than 0 are here and here. Now, you do have to be careful. Because it can't equal 0, we do have a breaking point. The first interval, keeping in mind this goes to negative infinity, stops at 0. And then the other thing you do want to always be careful about with these sign charts, and this is one of the reasons why you'll notice the values I'm plugging in, I'm using a different color. And so negative infinity to 0, union 0, where it starts back up, to 3. So greater than 0, 3 to infinity. Less than, you use the 2 intervals around the bounce where it's negative. So that finishes up the first half of section 2.7, which again, I think there should be some components of this that looked familiar.